Welcome everybody once again. So we are in our module 4. Today in this class let us see a few problems. Let us solve a few problems on the flow through circular channels and most economical circular channels. So this comes under open channel flow. Okay, open channel flow. So problems on how to find the discharge in circular channels and using these conditions, most economical circular channels, conditions for most economical circular channels, we will solve a few problems. So we will move on to the problems. The first problem is find the discharge through a circular pipe of diameter 3 meter if the depth of water in the pipe is 1 meter and the pipe is laid at a slope of 1 in 1000. Take chassis constant C equal to 70. So the section for the channel is circular. So we will draw a circular section. Let us draw a circular section. Okay. We will draw a smaller section. Otherwise, while marking, it will be difficult for you. Okay. So this is a circular section, okay, of the circular pipe. So the diameter is given as 3 meter. Diameter of the circular pipe is given as d meter. Let us take the center point as O. Now, if the depth of water in the pipe is 1 meter. So if the diameter is 3 meter, the radius will be equal to 1.5 meter. Okay. So the depth of flow of water in the pipe is 1 meter. That means it lies below the center of the circular section, below the center. So 1 meter will be approximately here, right? Approximately here. So the water level will be like up to this. Okay. So the water level is 1 meter. So this 1 meter is our small d. So depth of flow small d is equal to 1 meter. The diameter of the pipe, we will take it as capital D is equal to 3 meter. So from this, okay. So from this, our radius will be equal to 1.5 meter, 3 by 2. Now the pipe is laid at a slope of 1 in 1000. So I is equal to 1 by 1000. And also chassis constant C is given as 70. So we have already studied in our theory class when the depth of flow of water is below the center of the pipe, how to mark the angle theta. So we know we will draw a line. See, this is our depth of flow, okay, this point. So from this point, you draw a line meeting at O. So this angle is 2 theta, right? So if this angle is 2 theta, when we draw a perpendicular distance, perpendicular line, see this angle is theta. Similarly, this angle is theta. So totally it is 2 theta. Okay. Now, what is the wetted perimeter? See this distance. This is our wetted perimeter, right? So this distance is our wetted perimeter. So wetted perimeter will be equal to, so the radius is r. The angle subtended by the wetted perimeter is 2 theta. So wetted perimeter will be equal to r into 2 theta. R into 2 theta. R multiplied by 2 theta. So we get 2r theta. Okay. Now we know the formula for area and the formula for wetted perimeter. We will write the formula for area and the formula for wetted perimeter. We know the formula for area is equal to r square, radius square into theta minus sine 2 theta by 2. Similarly, wetted perimeter P will be equal to 2r theta. Now our aim is to find theta. See, we know the radius r is equal to 1.5 meter. Okay. So the depth of flow is 1 meter. If depth of flow is 1 meter, see, radius is 1.5 meter. So this distance will be equal to 0.5 meter. So we know radius is 1.5 meter. This perpendicular distance, this distance is 0.5 meter. So we can find what is theta. So how can we find theta? So theta is equal to, we will take cos theta, right? So cos theta is equal to, we will take this point as, let us take A, B, C. Okay. So cos theta is equal to OC by OA. So OC is 0.5 divided by OA is R, that is 1.5. So from which we get theta is equal to 70.53 degrees. We get theta is equal to 70.53 degrees. Now we have to convert this degree into radians. So in order to convert the degree into radians, 70.53 multiplied by pi by 180. Okay, in order to convert degree to radians, you multiply it by pi by 180, we get 1.23 radians. See, the reason is 180 degree is equal to pi radians. Okay. So in order to convert 1 degree is equal to pi by 180 radians. So 70.53 degree is equal to 70, you multiply it by pi by 180. Okay. Now we will find what is area. So we know area is equal to r square. So r square is 1.5 square into theta. The value for theta is 1.23 minus sine 2 theta. See, this theta here, sine 2 theta should be expressed in terms of degrees. 2 into 70.53 divided by 2. So we get the area as 2.06 meter square. Similarly, the wetted perimeter P is equal to 2r theta. So 2 into the radius is 1.5 multiplied by, now theta should be expressed in radians. So 1.23 we get 3.69 meter. See, when it is expressed in terms of sine and cos, you have to consider the degrees, otherwise you have to consider the radians. Okay. Now, so from this we will find the hydraulic mean depth M. So we know hydraulic mean depth M is equal to area by wetted perimeter. So 2.06 divided by 3.69, we get 0.5582. Now we will find the discharge. We know discharge is equal to area into velocity. So area into velocity. For velocity we will use the chassis formula C into root of mi. So area, we have obtained it as 2.06. So 2.06 multiplied by chassis constant is taken as 70 into square root of m is 0.5582 into I is 1 by 1000. We get the discharge as 3.407 meter cube per second. That's all. We will move on to our second problem. So the second problem is find the discharge through a circular pipe of diameter 3 meter if the depth of water in the pipe is 2.5 meter. So again, a circular pipe, okay, the diameter is 3 meter. Diameter of the circular pipe is 3 meter and the depth of water in the pipe is 2 meter. See, if we take the center point, the radius will be equal to, if it is 3 meter, diameter is 3 meter, radius will be equal to 1.5 meter. Now, the depth of water in the pipe is given as 2.5 meter. That means 2.5 means approximately here, right? So this is our depth of flow of water, 2.5 meter. Okay, so the diameter D is given as 3 meter. Therefore, our radius will be 1.5 meter. The depth of water, small d, is given as 2.5 meter. And the pipe is laid at a slope of, so I is given as 1 by 1000. C, chassis constant C is given as 70. So the difference between the previous problem and this problem is, previous problem, the depth was below the center of the circular section. Here, the depth is above the center point of the circular section. So if this is the case, how will we consider theta? See, so you can draw perpendicular, you can draw lines from the points. We will take this point as A, this point as B. We will take this point as O. So from A and B, you draw lines meeting at O. Okay, so when these lines meeting at O, see, previous case you all know, this is O, okay, this angle was 2 theta. But for this case, this angle should be taken as 2 theta. See, this is the angle 2 theta. Okay, if this angle is 2 theta, you draw perpendicular line like this. So this angle is theta and this angle is theta. Now our aim is to find theta. So how will we find theta? So in order to find theta, it is enough to find this angle. So what is this angle? See, this angle is 180 minus theta. This angle is 180 minus theta. Okay. So this angle is 180 degree minus theta. So now if we take the triangle AOC, AC is equal to the radius 1.5 meter. OC will be equal to see, this is 2.5 meter. So 1.5 meter, 2.5 meter minus 1.5 meter. So it is 1 meter. So OC is equal to 1 meter. AC is 1.5 meter. OC is 1 meter. So now, how can we find 180 minus theta? So cos 180 minus theta. What we get is cos 180 minus theta. So cos 180 minus theta equal to, this is equal to OC by AO. OC by AO. We know OC is equal to 3 minus 2.5. No. This OC is equal to, so up to this it is 1.5. So 2.5 minus 1.5, this is 1 meter. OC is equal to 1 meter. So OC is 1 meter divided by AO is the radius. So that is 1.5 meter. So from which we get 180 minus theta, cos 180 minus theta is equal to 1 by 1.5. So from which we get this 180 minus theta is equal to 48.16 degree. From which we get theta is equal to 180 degree minus 48.16. We get 131.84 degrees. Now converting it into radians, it is 131.84 multiplied by pi by 180. So we get theta is equal to 2.30 radians. Now we will find the area and the wetted perimeter. So we know the formula area is equal to r square into theta minus sine 2 theta by 2. So that is equal to r, the radius is 1.5. So 1.5 square multiplied by theta is 2.3 minus sine of 2 theta. So 2 into, here you have to take theta in degrees. So 131.84 degrees divided by 2. So we get, so you expand this, you will get area is equal to 6.293 meter square. Now we know wetted perimeter is up to this. See, wetted perimeter is this distance. This is your wetted perimeter. So wetted perimeter is equal to radius. See, this is the radius. Radius multiplied by 2 theta. So 2 r theta. So wetted perimeter is equal to 2 r theta. So we get 2 into radius is 1.5 multiplied by theta is 2.3 radians. We get 6.9 meter. Now our hydraulic mean depth M is equal to area by wetted perimeter. We get 6.293 divided by 6.9. Therefore, the wetted hydraulic mean depth M is equal to 0.912. Now we can find the discharge Q is equal to area into velocity. So area into, for velocity we will use Chassis formula, C into root of Mi. So area we have found it as 6.293 meter square multiplied by the Chassis constant is given as 70 into square root of M is 0.912 into the slope of the channel bed is 1 by 1000. So we get discharge Q is equal to 13.303 meter cube per second. So this is our answer. Now we will move on to our third problem. So third problem is calculate the quantity of water that will be discharged. So you have to find the Q. Calculate the quantity of water that will be discharged at a uniform depth of 0.9 meter. In a 1.2 meter diameter pipe which is laid at a slope of 1 in 1000. Assume Chassis constant is C equal to 58. So the diameter of the pipe is given as 1.2 meter. So the circular pipe is of diameter 1.2 meter. The uniform depth is 0.9 meter. So if the diameter is 1.2 meter, we know the radius will be equal to 0.6 meter. Radius is 0.6 meter. So the diameter is equal to 1.2 meter. Radius is equal to d by 2 is equal to 0.6 meter. Now the uniform depth of water is given as 0.9 meter. That means it lies above the center point. So up to this, right? So depth is 0.9 meter. So we will write the depth of flow small d is equal to 0.9 meter. Depth of flow of water is 0.9 meter. So now our aim is to find the theta. So how will we find it? Also the channel's bed slope I is given as 1 by 1000 and we are asked to assume Chassis constant C is equal to 58. So this problem is similar to the previous problem. So find theta. So you take this as A, B, C, subtend extent from A and B you draw lines joining at O. So now see this angle is theta. So this angle becomes theta. So totally it is 2 theta. So you can find first of all, so this angle is 180 minus theta. So find 180 minus theta, cos 180 minus theta and from that you can find what is theta. So you will get, I will give you the answers, you can do this as homework. So you will get theta is equal to 120 degrees. So that will be equal to 0.667 pi radians. Okay, now your final answer will be discharge is equal to 1.007 meter cube per second. You can do this of your own. We will move on to our fourth problem. So the fourth problem is a sewer pipe is to be laid at a slope of 1 in 8,100. So a sewer pipe is laid in a slope of 1 in 8,100 to carry a maximum discharge. So it is given maximum discharge. That means you have to use the condition for most economical circular channel section. So it is given maximum discharge is 600 liters per second when the depth of water is 75% of the vertical diameter. So now we will consider a circular section, and for this circular section the diameter, let us take the diameter as capital D. The depth of the water, that is depth of flow D, is given as 75% of vertical diameter. So 75% of the diameter of the pipe. So it is 0.75 D. Now find the diameter of this pipe. We need to find what is the diameter of the pipe. Manning's constant N is given as 0.025. Okay, so first of all, we will find the discharge. First of all, we will find theta. Okay, so in order to find theta, so it is given, we will take this center point as O. It is given the depth of water is 75%. So 0.75 D. We will write this as A, B, C. We will draw lines BO and AO. So this angle becomes theta and this angle becomes theta. So now this angle is alpha minus, 180 minus theta. This angle is 180 minus theta. Now we know AO is radius, so that is equal to D by 2. AO is the radius equal to D by 2. OC is equal to 0.25 D. Because radius is equal to 0.5 D, depth of water is 0.75 D. So 0.75 D minus 0.5 D, we get 0.25 D. So from this we can write cos 180 minus theta is equal to cos 180 minus theta is equal to OC by OA. So 0.25 D by AO is D by 2. So we get 0.5, from which we get theta is equal to 120 degrees, or theta is equal to 120 into pi by 180 to 0.0946 radians. Now we know area is equal to R square into theta minus sine 2 theta by 2. So R is D by 2. D by 2 the whole square multiplied by theta is 2.0946 minus sine 2 into 120 degree divided by 2, we get area is equal to 0.6319 d square. Now, wetted perimeter P is equal to, we know P is equal to 2r theta. So, we get 2 into d by 2 into theta. So, d into the value of theta is 2.0946. We get wetted perimeter is equal to 2.0946 d. Now, we will find the hydraulic mean depth M is equal to A by P. So, 0.6319 d square divided by 2.0946 d, we get the wetted perimeter as 0.308 d. Now, Manning's, what is given? Manning's constant N is given. We know Manning's formula is used to find the Chassis constant. So, we know the Manning's formula for Chassis constant. So, Manning's formula for Chassis constant is I will give you the formula. C is equal to 1 by n into m raised to 1 by 6. Now, we know discharge is equal to area into velocity. So, area into C into root of mi. Area is given as 0.6319 d square into Chassis constant is given as 1 by n into m raised to 1 by 6 into square root of m into I. So, m is 0.308 d into the slope is given as 1 in 8100 multiplied by 1 in 8100. So, Q is equal to 0.6319 d square into 1 by Manning's constant N is given as 0.025. 0.025. The value for M is 0.308 d the whole power 1 by 6 into square root of 0.308 d into 1 by 8100. So, from this we will get the discharge discharge is given as 6000 liters per second, right? So, it is nothing but 0.6 meter cube per second. So, we get substitute Q is equal to 0.6 meter cube per second. So, the only unknown is the diameter. We will get diameter is equal to 1.785 meter. We will move on to our fifth problem. Fifth problem is the rate of flow of water through a circular channel of diameter 0.6 meter is 150 liters per second. Find the slope of the bed of the channel for maximum velocity. So, we know for the circular section, most economical circular sections, we have the condition for maximum velocity and maximum discharge. Also given the chassis constant C is equal to 60. So first of all, the diameter of the circular section is 0.6 meter, right? So the diameter is 0.6 meter. So capital D is equal to 0.6 meter. The rate of flow is 150 liters per second. So Q is equal to 150 liters per second. That is equal to 0.15 meter cube per second. So for converting liters to meter cube, you have to divide it by 1000. Find the slope of the channel bed. We need to find what is I. Chassis constant C is given as a 60. It is given, we have to use the conditions for maximum velocity. So we know the conditions for maximum velocity. We have already studied in the previous class. For the most economical circular section, for the conditions for maximum velocity, we will write the conditions for maximum velocity. So for most economical circular section, condition for maximum velocity is theta is equal to 128 degree 45 seconds. Sorry. Yes, condition is theta is equal to 128 degree 45 seconds. Then the depth of flow should be equal to 0.81 times the diameter of the flow. The wetted perimeter M is equal to 0.3 times the diameter. So these are the conditions for most economical circular section to have the maximum velocity. Okay. Now we know the diameter is 0.6 meter. So if the diameter is 0.6 meter, D will be equal to, depth of flow D will be equal to 0.81 times capital D, that is 0.6. So we get 0.486 meter. So theta is the same. Also M will be equal to 0.3 times the capital D. So 0.3 times 0.6. We get 0.18 meter. Now we will find the wetted perimeter. We know M is equal to area by wetted perimeter, right? So for that, first of all, we will find wetted perimeter P is equal to 2R theta. So 2 into R is D by 2, diameter by 2, radius. Theta is 128 degrees 45 second. So if it is 128, I will write here, theta is equal to 128 degree 45 seconds. Convert it into radians, you get multiply by pi by 180. So we get 2.247 radians. So multiply this by 2.247. We get wetted perimeter is equal to 1.3482 meter. So now from this, using the condition M is equal to A by P, you have to find the area. So area is equal to M into P. Hydraulic mean depth multiplied by wetted perimeter. So hydraulic mean depth is 0.18 meter multiplied by the wetted perimeter is 1.3482 meter. So from which we get area is equal to 0.2426 meter square. Now we can find the discharge. So discharge is equal to area into velocity, area into Chassis formula C into root of mi. So we get area is 0.2426. Chassis constant C is given as 60 into square root of m. M is given as 0, we have found m as 0.18 multiplied by I. So I is what we need to find, right? Q is given as 150 liters per second, that is equal to 0.15 meter cube per second. So we will substitute Q is equal to 0.15 meter cube per second. Q. So the only unknown is I. We will get I is equal to 1 by 1694.7. So the bed slope is 1 in 1694.7 meter. We will move on to our last problem. So last problem is determine the maximum discharge of water. Again, maximum discharge. So most economical circular section through a circular channel of diameter 1.5 meter. So diameter is 1.5 meter. We have to find the maximum discharge when the bed slope of the channel I is given as 1 in 1000 and C is given as 60. So similar to the previous problem, the only difference is you have to use the condition for maximum discharge. So conditions for, fifth problem was the conditions for maximum velocity. Now for the most economical circular section, the condition for maximum discharge, I will give you the condition, you can solve this problem of your own. The condition for maximum discharge are theta will be equal to 154 degree approximately. Depth of flow of water D will be equal to 0.95 times capital D. Also, the hydraulic mean depth M will be equal to 0.3 times the capital D. So, using these conditions, you can use these conditions. Sorry, I think I made a mistake. Yes. Okay, your answer will be approximately equal to Theta is equal to 154 degree. Small d is equal to 0.95 times the capital D. M is equal to, no, you don't have this condition. Okay. So these are the two conditions for the maximum discharge. So using theta is equal to 154 degree, you will convert it into radians, you will get 2.6878 radians. Now your wetted perimeter P will be equal to 2r theta. So for this theta you have to use the radians. You will get wetted perimeter is equal to 4.0317 meter. Now you have to find the area using the formula r square into theta minus sine 2 theta by 2. So you will get area is equal to 1.7335. Now you have to find the hydraulic mean depth. See, there is no condition for hydraulic mean depth for maximum discharge. Only for maximum velocity we have m is equal to 0.3 times the diameter. Here you have to find the hydraulic mean depth using A by P. You will get hydraulic mean depth as 0.4299, and after this you can find the discharge. So discharge will be equal to 2.1565 meter cube per second. So that is all for today. Thank you.